flight.
Hydraulic temperature, Scott? -2 and holding since we passed the tower.
Test pilot Scott Crossfield is buckled in and ready for a ride to 40,000 feet, where he'll be cut loose for the first demonstration of this plane's abilities and performance. Flying chase will be Al White, North American's alternate, Joe Walker, NASA's chief test pilot, and the Air Force project pilot, Major Bob White. All vital observers today. They'll be at the controls of the X-15 in the near future.
Edward 003.
Winds 220 degrees at 12 knots.
Prime responsibility for getting the X-15 to drop altitude rests on the aircraft commander, Captain Charles Bach, and the co-pilot, Captain Allaby.
Penny Tower, 003, rolling now.
As the bomber climbs out, the litany of checkout drones on, item after item. Gauge, switch, and control are checked and rechecked. In the dim interior of the 52, Bill Berkowitz, launch monitor, has a close-up television view of system operation. The group has been this route before. 2 tries, 2 misses. The first try never left the ground. The second came agonizingly close, just 3 minutes from a drop, when a frozen valve canceled the effort. Delays are difficult to accept, but each time the system at fault was improved and a problem eliminated.
Fuse coming on now. Number first.
Roger.
Number 2 on now. Real slow to pick up hydraulic pressure. It grabbed off in about 5 seconds.
3 minutes to drop.
Going to jettison. Fuel jettisoning. Full jettisoning. Okay, good check. Prime's coming on now.
She's called Prime. Launch operator can't see it. Yeah, you got a blossom on the bottom one? They're both looking good. 30 seconds, give me ready to launch light.
Get a launch light on.
Launch light on. Okay, Scotty, you ready?
I'm ready when you are, buddy.
Okay, here we go with the countdown.
Got 8 of them going.
Roger.
Heading uphill at 33,000 feet.
Roger.
Looks good across the board. And I'm on number 1 and climbing for 35.
Roger.
Direction looks good, Scotty. Right on, you look real good.
Okay, fine. One up on 50. Level.
Right.
Take a little speed. I'm going to ease off.
Right.
Left turn. Right. I'm beginning to come around the final part of the turn. I dropped back in Mach number.
The record showed Mach 2.1, over twice the speed of sound, 1,385 miles an hour.
Burn out.
Roger.
On the first try, man and plane went 1/3 the way to the goal of 6 times the speed of sound. As the X-15 slows to subsonic speeds, the chase planes catch up and the glide portion of the flight begins. Now on a southerly heading, Crossfield begins his long glide to landing from 46,000 feet. Time in the air is precious, and the checkout continues all the way down.
Right.
Roll, the track. Here comes Central now. You ready? 9, parachute deployed, no fouled up. Roger. You're fouled up? No, the parachute, well, it's open. It's letting it down. How nice. 245. 245. It's pretty good crosswind, isn't it? A little bit, yeah. 240. Still 240. Gear is coming down, and it looks good. Nice and easy, Daddy. Shown 210.
Though researchers were concerned with the supposed impenetrable sound barrier, the X-1 slammed through this barrier to aviation progress with a series of flights well beyond Mach 1. The age of supersonic flight had arrived. A few years later, the X-2 made its appearance. Its mission was to probe deeper into the unknown regions of ultra-high speed and high-altitude flight. It set records, too, peaking out at 126,000 feet and achieving over 3 times sonic speed. Even while the X-2 was still flying, planners were looking toward the next step into the future, a combined airplane and space vehicle, the X-15. The plan calls for this craft to start at the dry lake and ride with a carrier plane out over Utah. Its progress will be watched and marked by tracking stations spotted along the flight path, a corridor known as the High Range. Masses of new information will be radioed back to ground stations. Flying beyond the atmosphere at ultra-high speed has its penalty: heat. As the atmosphere is re-entered, air friction will heat parts of the plane to a red glow, 1,200 degrees Fahrenheit. Past the critical re-entry phase, the X-15 approaches the Earth as an airplane, bringing our eyewitness back from beyond the sky. From the drop to the landing, one man, the pilot, will be in control. High-altitude rockets have shown that outer space is totally hostile to human beings. Man must have a spacesuit to survive. This multi-layer suit is complete with air conditioning, pressurization, oxygen supply. It gives the comfort and mobility needed to control an airplane or a spacecraft, yet it could sustain life on the moon. Suppose the pilot had to eject, bail out. Would this suit save him? A series of checks were made using the rocket sled to build up the speed to over 1,000 miles an hour. There were a few ripped seams, some minor damage, but the suit survived, and so would the man. This seat is a duplicate of the one in the plane. If an emergency arises, the pilot pulls the ejection handles. Rods rotate and clamp the ankles, holding the feet down and the legs in. Armrests fold the arms into the chest. While these tests continued, engineers readied a second sled. This one, a complete nose section. It was used to check the ejection cycle. Tests had demonstrated that all units worked separately. Now, how did they work in sequence with split-second timing? Our escape system was ready to handle any emergency. While engineers continued development work, production crews were scanning acres of blueprints and converting drawings to three-dimensional metal shapes. High in-flight temperatures demanded the use of an alloy new to airframe manufacture, Inconel X. This alloy retained strength even when red hot. As the number 1 plane of the 3-plane series neared completion, pilots and engineers were already investigating its flying qualities, using a device called a flight simulator. This valuable training device also uncovers bugs in systems, works out problems before the critical flight phase. An electronic computer takes the place of the airplane, and it responds by changing instrument readings, which the pilot interprets as flight progress. Runs by the hundreds were made from drop to landing to get the feel of the plane, note its response, improve its systems. Pilot training continued in the Navy's whirling centrifuge. Seated in a capsule, the man must show that he can retain control even when the force of the rocket engine is jamming him back in his seat. Over 500 pounds is squeezing him back, impeding his movements. A test director and a flight surgeon monitor the runs, ensuring that the pilot does not exceed his limitations. Re-entry practice is the second phase, where the capsule rotates to redirect the force downward, simulating scorching back into the atmosphere. The pull-up squashes him down with a force of over 1,000 pounds, but he maintains control, completing all missions satisfactorily. It was then shipped to Edwards Air Force Base to enter an exhaustive series of ground checks to prove each component. No item was too minor, nothing was overlooked. Special attention was given to the APUs, auxiliary power units. These jet turbine-driven units are the heart of the operating systems, vital because they give all the power to control the plane and operate its systems. Day after day, week after week, systems were run, checked, modified, rechecked, improved, until pilots and engineers agreed that we had reached a practical degree of perfection. Fitting the plane into its cradle under the 52 wing was another milestone. 4 round trips were made with the X-15 hanging under the wing while all systems were rechecked at altitude. Captive flights uncovered new problems, kinks that had to be worked out, eliminated. Then, on the 5th trip aloft, both man and machine were ready for the drop and glide flight to the lake.
Release.
It's a clean break. Looks pretty good here on a 36,250.
Every flight ends in a glide, since fuels are used in one all-out 3-minute burst. When the fuel is gone, it's a long downhill coast to the desert floor. Without power, the pilot has only one shot at the landing, so his skill and the maneuverability of the plane were critically judged.
Scott, don't forget the vertical.
Okay, we'll light clear the edge of the lake here. So coming off now. Clean separation. Good deal, buddy. Beginning the turn in. Got plenty of room. Good. I'm gonna land a little long on the lake, have a hunch. Collapse. Take it easy, the gear. You got it? You're about 30 feet. Now just hold her steady and you'll settle right there.
Safe landing was a mark of success. Performance was as planned. The X-15 is now the world's most advanced glider. The next step, adding power to sustain flight. This is the second airplane of the series. While number 1 was making its glide flight, another crew was readying the second model for engine runs. The first few tries will be made with well-proven engines, ones previously used in earlier X airplanes. Crew members move to the protective shelter of the blockhouse as the engines are primed for light-up. These multi-barreled rockets gulp liquid oxygen and a water-alcohol mixture to provide 16,000 pounds of thrust at cruising altitude. Even with these small engines, the X-15 could break all standing speed and altitude records. These runs climaxed 6 years of planning and work. The bird was ready for its maiden powered try. fledgling performed as planned. Born this day was a new tool for flight research. Using a new machine to probe into the unknown calls for caution, and weeks later the second flight showed that the performance could be repeated and excelled. Digesting the knowledge from these first tries, the program became more ambitious, and another step up the ladder was planned, one that would extend the operating area. Countdown for powered flight begins at midnight. The previous week has seen many test hurdles, each one met and overcome, each one establishing with greater authority the right of the X-15 to be in this fueling area. All the control points have been passed this far, and now the touchy, toxic, volatile propellants are added one by one. As tanks are gradually filled, crew members take long last looks into the vitals, then close the doors. Dawn finds the service carts being pulled away with the two aircraft again standing ready. Even the most carefully controlled experiment has its element of risk, and the sober faces of every member of the team reflect their concern. Each research flight has fresh new goals. Each one is a cautious step forward into unexplored areas. The intention of this flight is to make a straight climb to 80,000 feet, hitting Mach 2 at the peak. The now routine checks of plane and engine pass uneventfully, and just past 9 in the morning, the third voyage of the X-15 begins.
I got a fire, Scott. Like shut down. Plane shut down. Shut down. I'd like to shut it. Land on Rosemont.
In a split second, the plan of exploration is abruptly changed to one of survival as the pilot feels out the plane for damage and heads for Rosemont, an emergency landing area. Never has the pilot been more vital. Now it's his responsibility to get the plane on the ground safely if he can.
Hey, Scott. Jettison the ventral anytime. Ventral coming off now. Is the ventral off? It's off and the ventral is off. Roger, it's on the flaps.
Trouble came in pairs on this day. The engine failure was complicated by a structural break, and both were at this time unexplained. The plane was on the ground, the pilot safe, but there were new problems. Investigators found that the rocket engine had suffered an ignition failure, leaving a chamber loaded with explosives. When this mixture finally ignited, the chamber ruptured. This explosion triggered another series of events leading to additional damage. Under normal conditions, the tanks are almost emptied, but jettison in a nose-down emergency glide leaves more propellants, more weight in the fuselage. Because of this increased weight, the nose of the plane had to be higher than usual during landing. Although the touchdown was smooth, the nose-up angle was beyond the design limits, and the break occurred when the nose wheel slammed to the ground. A day and a half after the accident saw the airframe in its original jigs at the factory. The damage that seemed crippling was quickly repaired, and the broken halves rejoined. This whole project is one set to gain knowledge, and even from failures, lessons are learned. The fuselage was strengthened and landing gear was redesigned to absorb more shock. The rocket engines were modified to increase reliability. 5 weeks after the unsuccessful try, the plane, now whole and improved, began its trek back to Edwards Air Force Base. Weeks have slipped by since the accident, but the time has been traded for knowledge. More is known now. Certain hazards have been ruled out. The machine is better, more able. This is the #1 plane of the series, modified, improved, and set to show its capabilities. It hangs frosted, smoking, ready.
Looking real good from back here. And they look very good across the door. Back in the saddle again.